All right, let's go. We have been listening to the universe for less than 100 years. In that time, we built radio telescopes the size of football fields, pointed them at every corner of the sky, and recorded everything we could hear. Most of what we found was predictable. Pulsars rotating like clockwork, the soft background hiss of the Big Bang still echoing 14 billion years later. But some of what we found made the people listening go quiet. Not quiet the way scientists go quiet when data is boring. Quiet the way they go quiet when the data is something they have no category for. Something that breaks the pattern. Something that arrives without warning, without explanation, and without a return address. Every signal on this list has been verified, analyzed, and published in peer-reviewed literature. Every one of them remains unsolved. Some have candidate explanations that most researchers find plausible but unproven. Others have no explanation at all. And a small number have properties so specific, so structured, so difficult to produce by any known natural mechanism that the scientists who study them professionally have not ruled out the possibility that they are not natural at all. These are 10 signals from space that no one can explain. And the closer you look at them, the less comfortable the silence around them becomes. Number 1. The wow signal. The one that started everything. On August 15, 1977, astronomer Jerry Ehman was reviewing data from Ohio State University's Big Ear radio telescope. The telescope was scanning the sky as part of SETI, looking for narrow-band radio signals that would stand out against the broadband noise of natural sources. The telescope recorded something. A signal so strong, so precisely structured, and so perfectly matched to the theoretical profile of what an extraterrestrial transmission might look like, that Ehman circled it on the printout and wrote a single word in the margin. Wow. The signal lasted exactly 72 seconds, which is exactly how long the Big Ear's fixed beam would track a point source as Earth rotated beneath it. It appeared on only one of the telescope's 2 feed horns, consistent with a genuine point source from a specific direction. It was centered at 1,420 megahertz, the frequency of hydrogen, which had been proposed since the 1950s as the most logical frequency for interstellar communication. It was approximately 30 times stronger than the background noise of space. It has never been detected again. Dozens of follow-up observations using more powerful instruments have found nothing. No natural astrophysical source has been confirmed at that location. The wow signal remains the strongest candidate for a non-terrestrial transmission ever recorded. 47 years of silence have neither explained it nor replicated it. It sits in the data, circled in red pen, waiting. Number 2. Fast radio bursts. The universe is screaming, and we do not know why. In 2007, astronomers analyzing archival data from the Parkes Radio Telescope in Australia found a record of something that should not exist. A burst of radio waves lasting less than 5 milliseconds, but releasing in that fraction of a second as much energy as the sun produces in 3 days. It had arrived from outside our galaxy, crossing billions of light-years of space. This was the first known fast radio burst. Since then, we have detected thousands, and the more we detect, the stranger they become. Some are one-time events, appearing once and never repeating. Others repeat, sometimes on irregular schedules, sometimes with periodic patterns suggesting an underlying clockwork. One source, FRB 201-80916b, repeats on a precise 16-day cycle, active for 4 days and then silent for 12, with a regularity that no fully satisfying astrophysical model has explained. The leading candidates are magnetars, extremely dense neutron stars with magnetic fields 1,000 trillion times stronger than Earth's. But the most energetic fast radio bursts exceed what magnetar models predict. The periodic repetition of some bursts has no established explanation. There is another layer of strangeness that rarely gets discussed. Fast radio bursts travel billions of light-years and arrive at Earth lasting only milliseconds. To produce that much energy in that short a time from that far away requires a source that is physically small, because nothing can coordinate its emission across a region larger than light can cross in a millisecond. The emitting region of a fast radio burst is therefore roughly the size of a city. Something the size of a city, billions of light-years away, is outshining the entire galaxy it lives in for a fraction of a second. The scale of this is genuinely difficult to hold in the mind. It is not just that we do not know the source. It is that the source, whatever it is, operates at energy densities that have no parallel in our current understanding. Every day, roughly 10,000 fast radio bursts are estimated to occur across the observable universe. The sky is full of screaming, and we are only now building instruments sensitive enough to hear it. Number 3. The pulsar that should be dead. GPMJ 1839. In 2022, astronomers announced the discovery of a radio-emitting object unlike any pulsar ever seen. Designated GPMJ 1839-10, it emits an extraordinarily bright, highly polarized radio pulse once every 21 minutes. The slowest known pulsar before this discovery pulsed every 23.5 seconds. GPMJ 1839-10 pulses every 21 minutes, more than 50 times slower. Standard pulsar physics says that at this rotation rate, the object should be electromagnetically dead. The mechanism that generates radio emission in neutron stars requires a minimum rotation rate to function. Below a threshold called the death line, the emission mechanism shuts off. GPMJ 1839-10 is deep below the death line. It should be silent. It is not. Subsequent archival analysis found this object has been pulsing for at least 33 years without any detectable change. Something is generating coherent, structured radio pulses on a regular schedule from an object that our physics says cannot do this. We do not know what it is. Number 4. Oumuamua, the visitor that behaved like nothing natural. In October 2017, astronomers detected an object passing through our solar system on a trajectory that could only have originated from interstellar space. The first confirmed interstellar object ever observed. They named it Oumuamua. It was strange in ways that went beyond its origin. Its shape appeared to be highly elongated, perhaps 10 times longer than it was wide, unlike any known comet or asteroid. It showed an acceleration away from the sun that exceeded what solar radiation pressure alone could explain. It produced no detectable outgassing of water vapor or carbon dioxide, as a comet would when heated. And it tumbled in a way suggesting it was not a uniform solid object. Avi Loeb, the chair of Harvard's astronomy department, published a paper proposing Oumuamua's anomalous acceleration was consistent with it being a light sail, a thin, flat object pushed by solar radiation, and that its properties were more consistent with an artifact of technological origin than with any known natural object. When the Breakthrough Listen program pointed a radio telescope at Oumuamua as it departed the solar system, it detected no radio emission. It was not transmitting. But it also was not doing what a natural object should have been doing. The absence of a signal was not reassuring. It was a different kind of anomaly, layered on top of all the others. Oumuamua left the solar system and will never return. We had weeks to study the first interstellar visitor ever detected in our solar system. We do not know what it was. Number 5. The Galactic Center Repeater. ASCAP J173608. In 2021, astronomers using the Meerkat radio telescope in South Africa detected a repeating radio source near the center of our galaxy. The signal appeared for between 10 and 50 seconds, then vanished, then reappeared. Over several months of observation, the source appeared 13 times. It was highly circularly polarized, meaning the radio waves were rotating in a consistent direction, a characteristic associated with strong magnetic fields. It does not match the profile of any known class of radio-emitting astrophysical object. It is not a pulsar. It is not a magnetar. It is not a known type of variable star. It is not associated with any identified gamma-ray or X-ray source. The galactic center is the most extreme environment in the Milky Way. New classes of objects are being discovered there regularly. ASCAP J173608 may be one of them, or it may be something else. As of the most recent literature, it remains unclassified. Number 6. The Structured Repeater. FRB 202209128, and the pattern inside the pattern. In late 2022, astronomers using FAST, the largest single-dish radio telescope on Earth, detected a repeating fast radio burst and subjected it to analysis of unprecedented detail. The source emitted over 1,000 bursts in 2 months. What the analysis found inside the burst structure was unexpected. Across the sample of over 1,000 bursts, the central frequency of the radio emission drifted in a specific pattern from burst to burst. The subburst structure showed characteristic spacing. The mathematical relationship between burst duration and bandwidth followed a consistent scaling law. These regularities do not immediately suggest a natural explanation. They suggest structure, pattern, repetition governed by an underlying rule. Natural astrophysical emission processes do not typically produce this kind of multi-scale regularity. Magnetar models do not predict this specific pattern. The team was careful. They did not claim the pattern was artificial, but the words they used, regularity, substructure, characteristic scaling, are the words physicists use when they find something that looks like it was made according to a rule. We do not know what FRB 202.20912A is. We know only that it is patterned, that the pattern is real, and that our best current models cannot produce it. Number 7. LGM1. The signal they named Little Green Men before they knew better. In 1967, astronomer Jocelyn Bell noticed something unusual in radio telescope data from her doctoral research. A repeating signal, precisely periodic, pulsing every 1.3 seconds with a regularity that exceeded the stability of any known astronomical source. The initial designation among the research team was half-joking. They called it LGM1, Little Green Men 1. The explanation turned out to be pulsars. The mystery was solved. Science moved on. What this story obscures is the period between discovery and explanation. For weeks, Bell and her supervisor sat with data that had no natural explanation. The periodicity was too precise for a known thermal source. The flux was too high for a white dwarf. The signal repeated too rapidly for a binary star. For weeks, the best available physics had no answer. The lesson is not that anomalous signals always have mundane explanations. The lesson is that the gap between detection and explanation can be long. Right now, we have signals where that gap has not closed after decades. The WOW signal is 47 years old. GPM J1 839-10 has been behaving impossibly for at least 33. Sometimes the gap becomes a permanent feature of the data. Number 8. The 1977 Ohio anomaly nobody talks about. On the same telescope that recorded the WOW signal, using the same scanning protocol, there is another anomaly in the Big Ear data from the same era that receives almost no public attention. A series of structured variations in signal intensity detected from a direction different from the WOW source. Too irregular to be instrumental noise, too structured to be easily dismissed as interference, but not strong enough or clean enough to be championed as a candidate transmission. It sits in the data. It has been analyzed. It has no confirmed natural source. It is not discussed because the WOW signal dominates every conversation about Big Ear. This is the problem with anomalous signal archives. The dramatic ones become famous. The ambiguous ones accumulate in databases, occasionally reanalyzed, never definitively explained, never definitively closed. There is a long tail of signals in the SETI data record that are neither confirmed natural phenomena, nor confirmed noise, nor confirmed anything. They are simply open cases. And the number of open cases is larger than the public conversation about this search typically suggests. Number 9. The Hypno signal, a structured pulse from a star with planets. In 2016, a team analyzing data from the Rotan 600 radio telescope in Russia announced they had detected an anomalous signal from the direction of a star called HD 164922, a sun-like star approximately 94 light-years from Earth. The signal was strong, narrow band, and appeared to come from a region of space containing a star known to host at least one confirmed planet. The announcement was leaked before the team intended to publish and immediately generated enormous coverage. Within days, follow-up observations by multiple telescopes had found nothing at the same frequency from the same direction. The signal was not replicated. What makes this case interesting is not the signal itself, which may have been terrestrial interference. It is what the response revealed. Multiple major observatories immediately redirected time to follow up. The Allen Telescope Array spent days scanning the region. A single unconfirmed signal from a sun-like star with a known planet was considered worth this level of immediate response. That reflects the degree to which astronomers take the possibility of structured signals seriously, even if they rarely say so publicly. Number 10. The heartbeat signal. SGR 1935 and the pulse that should not carry information. In April 2020, a magnetar in our own galaxy designated SGR 1935 plus 2154 produced the brightest fast radio burst ever detected from a known source. It was the first time a fast radio burst had been definitively linked to a magnetar. It appeared to confirm the magnetar model. It appeared to close the question. Then, in subsequent monitoring, the same source produced something unexpected. A series of bursts with a sub-second periodicity embedded within them. A rhythm inside the signal. Not the rotation rate of the magnetar, which is known and accounted for. a different periodicity nested inside the emission, with a frequency that does not correspond to any obvious physical parameter of the source. Nested periodic structure inside an astrophysical burst is not something that standard emission models predict. Magnetars emit because of starquakes and magnetic field reconnection events. These are violent, chaotic processes. They are not supposed to produce nested rhythms. They are not supposed to pulse inside their pulse. The feature has been noted in the literature. It has not been explained. The magnetar continues to emit. The nested periodicity continues to appear. And the question of what physical process produces a rhythm inside a burst from an object undergoing catastrophic magnetic stress remains, as of the most recent analyses, open. 10 signals. Some arrived once and never repeated. Some repeat on schedules we cannot explain. Some come from objects that our physics says cannot produce them. Some have structures, specific frequencies, nested patterns, anomalous accelerations that sit just at the edge of what natural processes can plausibly generate. None of them are proof of anything beyond our current understanding, but all of them are questions. And some of those questions have been sitting open for decades without answers closing in on them. The standard response from the scientific community when asked about these signals is careful and measured. Natural explanations have not been ruled out. More data is needed. Extraordinary claims require extraordinary evidence. All of this is true, and all of it is appropriate. But there is a second truth underneath the careful language. The people who work with this data every day, who have spent careers building the instruments and writing the analysis software and sitting with the numbers, are not dismissive of the anomalies. They are attentive to them. They track them. They write about them in language that is technically precise and emotionally flat. But the choice to keep looking, to keep pointing the telescopes, to keep funding the programs, is itself a kind of answer. We are listening because we are not certain the signals are random. We are not certain they are natural. We are not certain we are alone. The universe is not obligated to produce signals that make sense to us, but the signals keep coming, and the silence between them, the silence where explanations should be, keeps getting louder. If you want to see more videos like this, click the video on the screen now.